great place to introduce some really fun technological gadgets and make some interactive puzzles. So with this introduction, I'd say let's get this game going. Yeah. Okay. Have a small cam here. So as you can see, the counter is ticking. Time is running away. You are all now special agents, and your mission will be to disarm this bomb before the counter runs to 0 and it goes off. Please pay close attention to my presentation. There are some clues hidden inside that will help you in the end. But for now, the first task will be that we need to get inside of the case to disarm the bomb. Now, I'd like for one of you guys, one volunteer, to please come up and try to open the case. Somebody, come on. Who wants to try? It's not difficult. Yeah, come on. See if you can find the user interface I built into it. Yeah. Hello, Special Agent Robert.
Hi.
Thanks. Please give it a try. No force, please. It's all automatic, so...
Access denied.
Well, okay, yeah, of course. It's not going to work. You have a hint or an idea why?
Probably I need the right. I don't have the right fingerprint.
Oh, yeah, exactly. Because what Robert sees, I don't know if you guys can see it very well. We have a fingerprint here. So what the problem is there's a fingerprint scanner. Now, I tricked you a little bit because usually in this phase of the game, we would already have solved lots of puzzles, and this would be quite near the end of the game. So what do you need if you want to pass a fingerprint scanner? You need the finger. Here, look at this. Whoop. So don't worry, yeah, this is Mike's. Yeah, he's waiting in the hospital. After my talk's finished, we're just going to put it back on. So it's been freshly cut. Here, why don't you try that?
Okay.
Access granted.
Thanks a lot. Okay, thanks, Robert. Please come back later when we get to disabling or disarming the bomb itself. Here, I'll give you a quick look on what's inside. This is what it looks like. So you have your cables, as you know from the movies, and on the left there you have your bomb diffusion tools. All right. But until we get to disarming the bomb itself, I'm going to tell you a little bit on how it was built and what kind of technologies we used to make it. All right, here's a short view so you can see it again, what it looks like inside the bomb. These are the cables, and you need to cut the correct cables in the end. And every cable has a number, which you can see on the board, and you need to figure out, of course, which cables you need to cut. All right. Now, first of all, I'll show you how this fingerprint scanner works. Of course, it's not a real fingerprint scanner. I mean, we want to make this stuff cheap and fun. And of course, it wasn't a real finger. Now, what we did is we used a combination of a magnetic sensor and a touch sensor to build this. And we just bought a small rubber finger from a magic store, put a magnet inside. So now when you come up and you touch the user interface, which is essentially just the touch sensor, if you touch the touch sensor by itself, the system will know, hey, no, yeah, access denied. But if you touch it with a magnet, the system will say, oh, okay, here's a magnet, yeah, now we can open up. So of course, if you got to escape game with your pocket magnet and you tried this with your pocket magnet, it will also work, but we have never had anybody try that up until now. All right, so what's inside of this case? Yeah, and of course, you have the two sensors I just told you about. We also have some more stuff, especially actors. Now, the actors and sensors we used for all of this are just simple ones. They have the state on and off. And so you either touch the sensor or you don't. The magnetic sensor is either on and off. And what we use to close the case or keep it closed is a magnetic lock. Now this lock is either on or off. If it has power, it's on and will keep the gate closed. And if you turn it off, the lock will open up and these springs here will just magically open the case. And with these tools, you can do a lot of fun stuff. Now, To build or start to build this thing, we use Raspberry Pi. You can use a 2 or 3 or some other device. And if you're like an electronics noob and you're not really into soldering and stuff like that, like me, yeah, I never had connections with this stuff until I started working on this, the Pi face is a nice addition because you can just plug it in and it has some nice features just to, for beginners to get started. But that's optional. Of course, you need your sensors and actors. And on the software side, we used an Equinox gateway. We use the Pi4J library to talk to the GPIO or the Pi-face inputs. And for communication, we use ECF OSGi remote services. So this is the architecture, what it looks like in one of the games that we built using this technology. Now, usually you don't just have one gadget. You have more of them. Like for instance, on one side of the room, you've got like a checkerboard, and one of the checkerboards you rigged with a magnetic sensor, and then you put a magnet in your king, and as soon as the king is placed on the right spot, you want to do something on the other side of the room. Turn on a light, open a door, whatever. So it makes sense to build small units of these gadgets and have them talk to each other. Now to do that, to do the communication, we used OSGi remote services. Now, I hope a lot of hands are going to go up now. Who knows what an OSGi service is? Yes, okay, that's very cool. Just a quick review of my take on it, really practical. If you want to have one of these guys, OSGi service, first thing you do is you create an interface, standard Java interface, you create the implementation for the interface, and then all you need to do is you need to register your service either through the API or you use a declarative services. Now, to turn just a normal, standard, local OSGi service into a remote service is totally easy. All you need to do with ECF is you give it some properties, and that's it. Voila. Now you have your remote service, and you can use this service from other gadgets. Now, I really love working with this, because first of all, it's type safe. And the way you program when you create these gadgets is the same way you would when you work with a local OSGi service. You actually, from a programmer view, when you're coding, you don't care if it's a remote service or if it's a local service or on which gadget the service is. You can just consume it and use it. And it's also very easy to test these kinds of setups. I mean, if you have 4 or 5 gadgets, Raspberry Pis, and you're at home because you're doing this for fun, and you want to test this stuff, of course you don't have 4 or 5 Pis and they're all running, you have one. So to test, to see if your gadget setup for the gadget is working correctly, you can just mock these other services and then test if your gadget behaves correctly. You can do that for all of them, and then the chances are it'll work if you put it in the big picture, and it actually did. So that works really, really well. Now, I use ECF implementation of OSGi remote services. They have some couple of nice features. The first feature is that you can switch the technology, the distribution provider technology, which is responsible for how the remote services talk to each other. Now, I just use the generic implementation, which uses local area network and TCP to talk to each other, but you could use these other kinds of technologies. You could route your communication through a server if you want to use the MQTT features. But this is on a lower level. If you work on your game and your programming, you don't really need to care about that. You can actually switch that later or use a different system while testing than you do in production. What they also have is discovery providers. Now, I love these because it saves you all this configuration stuff of which IP, which gadget it has, which IP, and how do you talk, and which services where, because they can get discovered automatically with just a little bit, or actually with zero configuration. And that they will leverage the dynamic capabilities of OSGi services so that when they discover a service, it just pops up as a service, just like any local service you would have. Now, just a quick view on the way these input or these sensor and actor services work. Introduced a basic service just to give it a name, so I know what this thing is called. And the first thing you want to do if you have like your sensor, your magnetic sensor, is you want to ask it, what's up? Are you on? Are you off? And with an actor, like for the magnetic lock, you might want to remote control the guy from outside. and want to turn it on or turn it off. Now, the second thing that you usually want to do is you want to get notifications when the state of one of your sensors or actors change. Now, this is a little bit more complicated using remote services because you can't just have your standard Java observer API like add listener, because the listener would get serialized when it's sent over the network and it wouldn't call back. Now, for situations like these, OSGi uses the whiteboard pattern. And this introduces another interface, which methods are called when the state changes. Now, this is for me, it took a little bit to get my mind wrapped around this at the beginning. But the way it works is that if you have a gadget or an application that wants to receive notifications, it will put up a remote service to get these. Now, to differentiate these kinds of observables from your listeners, I call them sniffers. So just that I know it's a little bit a different concept. So what you do is you put up a sniffer service, and you say, hey, I'm interested in listening to state changes from sensors. And the sensors themselves, since they're also running in an OSGi gateway, they will consume these services and check, oh, okay, there's a service interested in listening to my state changes. I'll just broadcast my state changes whenever something happens. Okay, so now we have lots of gadgets and we have all these sensors. And during this escape game, when the team is playing, you usually have an operator outside. And he's watching and observing, looks what happens. So he needs to know what's going on. He needs to see the state of the sensors and monitor if everything is working correctly. I mean, it could happen that a sensor gets broken or goes rogue or something doesn't work. So you want to give this guy the possibility to interfere, maybe to even use the remote control to open some doors if the system doesn't behave as it should. Now, this operator application looks like this, and I'll demo it for you real quick so you can see it in action. Now, this is it, smaller. So here you see all the sensors and actors I have in my box. Now, I'd like you to pay attention to the bomb lid magnet. This is just a magnet that measures if the lid is closed or not, and it will, inside it will change it will turn on the magnetic lock. All right, so I close the lid, and you saw the bomb lights internally went off, and the magnetic lock on the bomb went on, so now it's closed again. And to demo really quick that you can really remote control this, in case the fingerprint scanner doesn't work because it's broken, he could just, from the outside open it in the right moment. Of course, he has a camera, so he can see what's going on. Okay, now another application that's in this system of gadgets talking to each other is this little guy here. Now this is also a Raspberry Pi, and it's running a JavaFX application. Now, this is for the players, because they want to have some kind of information on what's going on. What's my feedback when I try to open the bomb or when I cut the cables. So this is the bomb monitor for the players in the game. Now, when you have an application like that, you want to give it, or we wanted to give it this like James Bond spy feeling in the UI, in the user interface. Now, and I already mentioned that we use JavaFX. If you want to have this kind of UI, you want to use animation, sound effects, stuff like that, JavaFX in the Java world is just a no-brainer. And one thing that's really nice about JavaFX is that you have the similar designer. I mentioned this because we're building a game. And while building a game means you have your start plan, then you start working on it, implementing it, and then it changes. And then it changes and changes and changes, and you do other stuff. Same thing as with the gadgets and the services. It changes. At first you thought you'd do this, and then you come get a new idea and you try something else because you want to make it fun. And making it fun is iterating. And the same is true for the graphics. So you sit together with a graphics guy, hopefully somebody a little better than me, and you can make this look really nice. Now, if you want to combine OSGi and JavaFX, you immediately land with FX Clipse. because this is just a perfect tool to do that. You have your Equinox runtime. You can use JavaFX UI. You can use Eclipse dependency injection to program, which is just fun. And you can use FX Clipse core APIs, which just brings some other helpful stuff to the A4 APIs. Now, when you're inside of this application, you have numerous ways to consume your OSGi services. And they're mainly just the same ways you would consume your local OSGi service. From the perspective of using this, it doesn't really make a difference if it's remote or if it's local. You can use a service tracker, declarative services. You could use add inject with Eclipse DI. I wouldn't recommend it, though, because that's not dynamic. And you can use the add inject add service API from FX Clipse, because the dynamic, or that it's dynamic, that's the important stuff that you need to realize, because since it's remote, you can't expect the stuff to already be there when you start up. It could come later, or maybe you want to reboot a gadget, so you have to be sensitive for services coming and going. Now, I guess lots of you, if you've heard of FX Eclipse and you've heard of JavaFX and you've heard of E4, know that there are E4 JavaFX renderers from FX Eclipse, and you can do JavaFX applications with E4. Okay, that's cool, and we did that for the operator I showed you. But if you want to create something like this, some cool, just small applications, that's really way too much for that. You don't need all the E4 parts and perspectives. You want to go directly with JavaFX UI. Now for this, there's a nice wizard, and I know that lots of people just miss it, where you can create just a small JavaFX, as a minimal JavaFX OSGi application using Eclipse DI, and then you have all your programming tools to really make cool dynamic applications without the E4 header. So, yeah. The game's somewhere in this game, you need somebody who is responsible for the clock ticking. Now, we decided to do this on the BOM monitor. We didn't want to do it on the operator because I thought it would be important for this system to be able to work without operating software. You don't need the operator. Operator is just for controlling, but if you don't have it, you could play the game without. So we have the clock ticking on this small device. And of course, we want to be able to see what's happening and maybe to remote control this. So we have the same thing again, just a little bit on the higher level. The BOM monitor itself registers lots of input sniffers to register what's going on with the magnetic sensor and touch sensors and the cables and everything. And it uses these inputs to change its game state, and so that you can monitor the game state from outside. We have like the game sniffer, whiteboard pattern again, and you can use the game service if you want to remote control this thing, like I did at the beginning when I started the game. Here, let me show you that just really quick. This is that up here. So now I could also, if I think, oh, we're running out of time, my guys are a little bit late, I could add some time, or I could remove some time. And here I see the time that's ticking also here, and I see the game state. So where are the players currently in the game? Another thing that we did, using the same technologies, is we built a small hint monitor. Now hints are there for the players if they get stuck. I mean, we have a chain of problems, and if you get stuck and you don't know what to do, there's a point where you get frustrated. Now, that's the point where the operator of the game can give you hints so that you can continue playing the game and you get to the next step and still continue having fun. Now, to do that, we built another small application that looks pretty similar to your BOM monitor. And of course, we used an OSGi remote service so that from the operator, we can send messages to the display. And of course, show the time, so you know how much time you have left until you're done. Now, whoops, I didn't want to go here. Where's my Eclipse? I'm going to fire up one of these and show you another cool thing that you can do with the OSGi services. Since it's just an OSGi service, you don't really need to use this guy remotely. You can also use this guy locally and use it to build a small test control, so that when you're developing just this software, you don't need to start up your whole system. You can just develop it locally and use this to test it. See if animation is nice and if everything is working correctly. All right, so that's this guy. Yep, that's what I just showed you. Now, that's a good chance to demonstrate the dynamic capabilities in the operator. So in the operator software, we also have a tool so that you can manage these services. Now, I want to start one of these game services over here, and hopefully it will turn up. Bang, there it is. So the operator software was listening for hint display services. ECF discovered that there's a new service, it put it up, and the operator just created the UI for this display service automatically on the fly. So, I can't, here we go. Let's cycle some hints on this thing, because now is the time to have a look at our bomb. Now that you know how it works and what's going on, we should go on and try to disarm it. Now, who caught the hints? Good, because that's good, because then you were also mesmerized by my talking that you didn't really pay attention and see it. Yeah? But luckily for that, I put them on here so you can, I'll put it on camera so that you can watch the hints again, and I'll ask my special agent to please come up here and execute your will, because now you need to figure out what to do. While you're working on that, I'm really excited actually that I'm able to present this to you here today, because actually this story started at EclipseCon 2 years ago, for me at least. At the time, my friend Mike came back from Hungary, and he was really infused with escape games because he discovered them there, and he said, whoa, there's almost no escape games here, I want to build an escape game. So he went ahead and did that, and he invited me over for November to test his first game that he built, completely analog game. Before that, I was here, EclipseCon, 2 years ago, and I visited a talk by Wim Jongman that was called Cooking an Egg with Eclipse Communication Services, I think. Anybody here saw the talk, maybe? Yeah, well, I thought it was a great talk. It was just marvelous. I was completely hooked right away, and on the same day, I ordered my Raspberry Pi and stuff over my phone because I wanted to try this and work on this. And so I came back, the stuff arrived, I played with it, I did some small projects at home. Actually, I built a sensor for like a door to our kitchen so that we would know if we leave it open, so our child wouldn't just wander into the kitchen if we're cooking or anything. But that got a little boring because it didn't have the feel of a real project. And when I got to Mike, and he showed me his escape game, and I saw how much fun it is, we started talking about how we could use the stuff I had just learned to make these games more fun. And about a year later, with lots of experiments and stuff, yeah, we built the first game, with the bomb disarming simulation on the end. And since then, we've used this stuff in all kinds of other games. Just parts of it in one game or different stuff. And we use the hint monitor even in the analog games, yeah, because it works so nice. Okay. So we're coming up on 5 minutes, special agents. I really hope that you figure this out. Otherwise, we're going to be in deep problems. Somebody ready to come and try? Yeah, you can scream in. I mean, which cables you think should be cut, if you want to. When I started out with this, as I said before, I don't know much about electronics. I'm a software developer. I work at a company. We have we manage software for the German government for courts of law, and it's a Java EE application with a RCP front end. So I know a little bit, we use Eclipse technologies, of course. So I know about OSGi services and such, but I've never, played around with Raspberry Pis or electronics or stuff like that. So I still found it pretty easy to get started, especially with this simple setup that I'm using here. Just easy services on off. Kinds of things, and using these technologies, we could really get ahead pretty fast. We built all this on my spare time, since I have a normal job, so I need to do that first. And all of this was done on weekends and evenings. So I really encourage you, if you want to play around with this, go ahead and try it out. Yeah? You will get cool results pretty quickly. So maybe we could get half of the room working on the first set of numbers, A, B, and C, on the left side on the second set of numbers, so that we can combine efforts on this. And if you get under 2 minutes, I'd suggest you just guess and cut any. If you want to be really cool, you can wait and try to cut it so it stops exactly at 007. If you want to stop at a specific hint, just tell me what you need, what you want to see. You guys got A, B, C, D, E? All right. So who wants to come up and take the bomb disarming tools and just give it a try? Come on. Doesn't matter, just come up. Maybe somebody will scream in and just say, do this or do that. Yeah, just try it. It doesn't matter. Hello, Special Agent Achim.
Hi.
Okay, now you can take your bomb diffusion tool.
Yep.
Can you all see that? What's going on? All right. So,
Anyone?
cut one of the cable, please.
Which one I should cut? First one. Pardon?
First one?
Third one might be.
You mean the... It's a little bit... Let me... No! Don't pull the power plug. Yeah, do it. Cut any.
Okay.
Cut any.
So I'll cut the black one.
Ha ha.
Thanks, Achi. Thanks a lot. Okay, yeah, well, next time I need to make the hints a little bit easier. Thanks for the input. All right, anybody have any questions? Otherwise, that would be the end of this presentation.
Can you show us the results if we cut the right one?
Yeah, sure, I can. All right, let's move over to the operator, reset the game, start it. Okay, now I need to initialize. Where did I put my finger? Oh yeah, over here. Okay.
Access granted.
Now, the correct solution would have been cable number 5 and cable number 4D. So now if I cut or just pull cable number 5, it comes down to the same thing.
Oh no, someone is trying to disarm me. Better speed up a bit.
I'm sorry, I didn't show you what's going on. Let's do it again. Okay, reconnect and cut.
Oh no, someone is trying to disarm me. Better speed up a bit. Access granted.
Yeah, so what happens is you cut the first one, you should be down to like 5 minutes or just a few, so it gets a little bit faster. And then, what did I say, cable number 5 and 40.
Bomb disarmed. Congratulations, you saved the day.
Thanks, guys.